So for this topic, we are talking about unit circle and trig ratios. So what's a unit circle? So a unit circle is actually a circle within a Cartesian plane. So a Cartesian plane is a plane with the y-axis and also the x-axis. So for it to be a unit circle, the radius need to be 1 unit, and therefore the x-intercept will be 1 and -1. The y-intercepts will be 1 and -1. Another important thing to note for unit circle is every single calculation needs to begin on this line over here. And because of that, because we started here, so we will call this as 0 degrees. This one will be perpendicular, and therefore this is 90 degrees. And for this side, from here, it's 180 degrees, which is a straight line. And going here, 270, and going back, 360. So we understand that a full circle with a full turn is 360 degrees. And if we also learned in the previous chapter that 1 pi is equivalent to 180 degrees, and 2 pi radian is equivalent to 360 degrees. So if we want to write it in the unit circle, this will be 0 and 2 pi. 90 degrees will be pi over 2. 180 will be just pi. And 270 will be 3 pi over 2. So if we have a point, for example, if we have a point that's 210 degrees, how does it look like in the unit circle? So we have a Cartesian plane. 210 degrees will be, we need to start from here. We need to spin from here to here, which is already 180. In order to get 210 degrees, we need to spin it extra until here. So this is 210 degrees. So this means that 210 degrees is positive, and positive always goes anti-clockwise. So what if there's another angle that's, let's say, negative 150 degrees? If positive goes this way, negative needs to go the other side. And so spinning this 150 will get to this point. So 210 at 150 is equivalent to 360, which is a full revolution, and therefore 210 degrees is equivalent to negative 150 degrees. It will be the same if it's in radian. So 210 degrees is actually 7 pi. 7 pi over 6 radian. So 7 pi over 6 radian is equivalent to negative 5 pi over 6 radian if it goes the other way. So they will end up on the same line, which is this line. Another thing that's important to learn for this unit is the magic word. So the magic word is SACE. So what does SACE means? So in this case is sine, and C is cos, and T for TOA is tangent. So this works really well if it's a right angle triangle. So let's say we have a right angle triangle with the right angle. So this is the angle here. The opposite of the angle is the line that's right opposite this one. So we call this as the opposite. The one that's always the slanting one, which is the longest side of a triangle, it's called a hypotenuse. And the one that's right beside is called adjacent. So how does this fit into the magic word? Sine is equivalent to OH. So the one that comes before this, which is the O, needs to be the opposite one, which is on top. And the H is the hypotenuse, which is at the bottom. For cos, because cos is AH, so cos is equivalent to adjacent over hypotenuse. And tangent, because it's OA, so tangent is opposite over adjacent. So that's the magic word, which is SACE. So how does SOHCAHTOA fit into the unit circle? So in the unit circle, let's say I take out one part of the unit circle, which is the first quadrant. By the way, in the unit circle, we call the first part as the first quadrant, which is here. This is the second quadrant. This is the third quadrant. And this is the fourth quadrant. So let's say if we take out the first quadrant, it will look like this. This is X, this is Y, and this is the circle. And okay, this is 1, and this is 1, and this is 0. So let's say we have a point P, and P is a point that is on the unit circle. So let's say we have a point that is P, and P has a coordinate of X and Y. So if let's say we join this to form a sort of a right angle triangle, we can see that this is the angle, and the opposite of the angle is actually the Y value, which is this one, and the adjacent of the angle is actually the X value, which is here. And what about the hypotenuse? Because this is a unit circle and all the radius is 1, the hypotenuse is a radius as well, and therefore this is 1. So what if we want to write sine theta? So sine theta is actually, we use the formula here, opposite over hypotenuse. So it's equivalent to the opposite of this angle, which is Y, over hypotenuse 1. So sine theta is actually Y over 1, which is equivalent to Y. So what about cos theta? Cos theta is actually, according to this formula, adjacent over hypotenuse. So adjacent over hypotenuse is the adjacent of this angle, which is X, over hypotenuse 1, which is equivalent to X. So we can also write the coordinate of P as, instead of X and Y, it could be X, because X in this case is cos theta. So we can write this as cos theta and sine theta. So from the previous chapter, we also learned that the equation of a unit circle is x squared plus y squared equals to r squared. But in this case, because the radius is 1, so we can say that x squared plus y squared is 1 squared, which is 1. So this is the equation of a unit circle. And because x is actually my cos and y is actually my sine, I can also write this as cos squared theta plus sine squared theta is equivalent to 1. So this is a very important equation to remember, because it will be very useful in the following questions that we need. So this is a very important equation. And also we need to know that all points of the circle, because now my cos is my x, and my cos is my x, and x has a maximum value of 1 and a minimum of -1. We know that a cos theta lies on, it's in between -1 and 1. And because my y value has a maximum of also 1 and a minimum of -1, we know that y is related to sine, and therefore my sine has also a range of -1 to 1. Okay, so from this, what do we understand about the tangent? So because we know that a tangent is opposite over adjacent, so opposite in this case for my angle, opposite is my y, so I can say that my tangent theta is equivalent to y, and my adjacent will be x, so tangent is actually y over x. Or also we can write this as, because y is actually my sine, I can say that tangent theta is also sine square over cos square, sine theta over cos theta. So just now we were learning about unit circle, and just for a recap, the unit circle is a circle with the radius 1 and the center 0, 0. So let's say I draw this again. And there is another important information that you have to know, which is all Seaview teaches cute. So what do I mean by that? A is for all, S is for sine, T is for tangent, and C is for cos. This is also some very important information. So it means that in the first quadrant, all means that sine is positive, cos is positive, and tangent is positive. All stands for sine, cos, and tangent, and all of them are positive. So in the second quadrant, there is a sign here. What does that mean? It means that sine is positive, but cos and tangent will both be negative. So if it is this case, for tangent, tangent for the third quadrant is a positive, the sine will be a negative, and the cos will be a negative. So in the fourth quadrant, sine will be negative because it's only the cos that's stated here. The cos is positive, and the tangent will also be negative. Suppose we have a question like, use the unit circle diagram to find the values of cos negative 270 degrees and sine negative 270 degrees. How do we solve that? So drawing the unit circle, we need to remember that all our calculation needs to start from this point. So we start from this line and spin a negative 270. So from just now, we learned that if the value is positive, we will go anti-clockwise. But because this is negative, we are going clockwise 270 degrees. So we need to start from this line here, and we will spin 270 degrees until we reach here. So this is the line that we want, and the point will be on the circle here. And we know that the coordinate for this point at the circle is actually 0 and 1. So how do I know the cos of negative 270? From just now, we learned that the x coordinate is the cos, and the y coordinate is the sine. And therefore, the cos negative 270 is the x coordinate after it has spun negative 270, and therefore it is 0. And for sine, it will be the same. Spinning 270, we get sine negative 270 is 1. So after you understand that, we need to understand about the periodicity of trig ratio. What does it mean? So sometimes, from what we have learned just now, we know that it could actually spin just a full circle, which is 360 degrees. But what if we have a point that is above 360 degrees? So let me give you an example. So let's say we have a point that has 500 degrees. So does this make sense? Let's go back to the Cartesian plane, x and y. We always need to start from this line. Okay, and in this case, because 500 is positive, we need to spin from here to here, which will make a full circle, but that's just 360 degrees. We sort of need 140 degrees more. So we need to, from here, continue on until it's 140 degrees, and therefore it is this line over here. So is there any difference if it's 500 degrees or 140 degrees? Not really if it's on a unit circle, because they will end up on the same line. So therefore, 500 degrees can be written as 140 degrees in a unit circle, and it will still look the same. So if this is in radian, so let's say I have something that's a sort of 2.5 pi radian. So I know that, okay, let's say we make it negative. So we know that we always need to start from here. And if it's a negative 2.5 pi radian, I know that negative 2 pi will spin from here to here, because 2 pi is sort of like a 360 or a full turn. And we still need a half pi. So I need to spin this up to here, and that's where I stop. So this line is the line that I want, and therefore this is the same as negative half pi radian. So we can say that negative 2.5 pi radian is the same as negative half radian. So it means that for periodicity, if we want to calculate something that is above 360, even if it is like 750 degrees, it could be 750 is 360 plus 360 plus 30. So this is equivalent to 30 because we can remove the multiples of 360, or we can actually remove the multiples of 2 pi to get the answer.